All right, assalamu alaikum everyone. Let's begin. So we were doing circular measure, and today is going to be the last session that we spend on this. Tomorrow we start trigonometry, inshallah. Now, you can let me know if you have any questions from the worksheet or from any of the recent papers. We will be discussing those problems today so that tomorrow we can start our next topic. And if you don't have many problems, we could perhaps start our next topic already, but now it depends on you. If you have problems, you can let me know and we can discuss them. So remember what we've done in this topic. Primarily, the new concepts that you have in this topic are just this: the concept of radian, the conversion between degrees and radians, right? And then you have this arc length formula, S equals r theta, where S represents arc length, r is the radius, theta is the angle in radians, angle of the sector in radians, and the other formula was the area of sector formula, half r squared theta. Again, theta here has to be in radians as well. Apart from this, the other concepts that you use in this topic are what you have done in O levels already. So things like basic trigonometric functions, sine, cos, tan. There are some angles for which you have to use exact values, but you can find those from your calculator directly. You just have to make sure that you show that working, and that's going to be enough. Then area of triangle, you've done this in O levels as well, half into base into height, half AB sine C. You need to know these area of triangle formulas. If you have to find area of segment, you just find the area of sector, subtract from that the area of the triangle. This is something that you need to know about. And then these angle properties that you've done again in O levels already, some of these properties, they are used quite often in this topic as well. All right, so the new concepts that we have in this topic are not many. So today now, therefore, is going to be the last session that we spend on this. You can let me know whatever problems we have. We will try to discuss all of them in our today's class, inshallah. Okay, so you can let me know in the chat box or verbally. You can tell me if you have any questions from recent papers. You can tell me what the paper number is. So I can just copy it from there. Let's start with this first one that Hazim was asking about. That's question number 17. And those of you who haven't attempted these questions yet, please start. I don't know how to make you realize that if you're not practicing, you'll just forget everything. So there's not enough time left for that you keep forgetting stuff, and then you won't have much time for revision later as well. You have you have other subjects as well, so many papers to prepare for. This is pretty much the last chance that you have before your Cambridge exams to cover the whole syllabus thoroughly. You can't really miss this chance as well. P1 circular measure worksheet. Okay, let's start with this one. Question number 17 from the worksheet. Okay, Rajal, we'll have a look at that. And I might send something on the WhatsApp group as well. Naima is asking about question number 16 as well. Okay, so let's start with this. We'll try to be a bit quick so we can discuss as many of these questions as possible. So the first one is question number 17. Okay, let's start with this one. Okay, so in the diagram, OAB is an isosceles triangle. Isosceles triangle is a triangle that has two equal sides, right? We are given that OA equals OB, and the angle AOB is 2 theta radians. This angle is 2 theta. Arc PST, this arc, has center O and radius R. The line ASB is a tangent to the arc PST at S. So this is the tangent to the arc ASB. this is all the information that we have. In the first part, it says, find the total area of the shaded regions in terms of r and theta. Now it's in a isosceles triangle and we have a sector in the middle. The area on the left side is going to be equal to the area on the right side. So you could perhaps find the area of one of these regions and then multiply that by 2. That is one possibility. Or we could just calculate all of that directly as well. That's your choice. So how would you describe the shaded region? The shaded region is basically area of that big triangle minus the area of this sector, right? That's how we can do this. Find the area of the big triangle, subtract from that area of the sector. Now, how can we do that? What information do we have? We have to find this in terms of r and theta. So everything has to be in terms of r and theta. Now, how do you find area of sector? That's pretty straightforward in this case. Now, this is very important, by the way. When you're doing these calculations, please make sure that you clearly write on your paper what exactly is it that you're calculating. So don't just write numbers like this. Okay, you're in your mind, you're calculating area of sector, and you would just write 1/2 into r squared into 2 theta. In this case, there are not too many figures that you can have here. For example, you have a sector and you have a triangle. There are not many other shapes that you have in this figure, but in more complicated questions, there are a number of different shapes that are there on a particular diagram. If we are just writing numbers like this, it's not really easily understandable for the examiner that to basically figure out what is it that you're trying to calculate. So always write descriptions on the sides to make it easier for the examiner to give you marks. So in this case, for instance, what you're calculating here is the area of the sector. So right here, area of sector. Which sector? We're talking about the sector OPT. That's the sector that we're talking about. So OPT. Write this clearly. If you don't want to write it fully, at least write this much, that this calculation refers to this figure, this part of the diagram, sector OPT. Okay, at least write this much to make it easier for the examiner to understand. I'm checking some exams this week, and it's so difficult to understand the working in these circular measure questions because people just keep writing numbers here like this. They'll have half into something that will evaluate to something, then you'll have some other calculation here without writing any description of what it is that they're calculating. And if the examiner can't figure out what you're doing there, you won't get marks for that. Okay, even if the working is correct, especially sometimes when they ask you to prove something. In those questions, they have the answer given in the question already. For example, in this case, they might have given you some value for the area and ask you to show that the area of the shaded region is this. In such questions in particular, where you have to show something, examiner is very particular about the steps that you're showing in your working. If they're not clear enough and the examiner does not understand what you're doing in every single step, you will not get full marks for that. So please make sure that the descriptions are very clear. Okay, so in this case, for instance, you could say area of sector OPD is that's half into r squared into the angle, which is 2 theta. Okay, now let's simplify this. 2 and 2 get cancelled. Area of sector turns out to be r squared theta. Okay, what about the area of the triangle? We have two formulas that we generally use for area of triangle: half into base into height, or half into two sides, the product of two sides, and sine of the angle between them, half AB sine C, right? We can use any one of those two formulas. How do you do that? It's an isosceles triangle. Remember the property of isosceles triangle, that if you draw a line from one vertex that is perpendicular to a side like this. This is perpendicular, right? Because this is radius and ASB is tangent. If it makes a 90 degrees here, this side AB that is divided into two equal parts. So AS and SP, they'll be equal to each other. All right. And not only are they going to be equal to each other, the angle is also going to be split equally. So this angle is 2 theta. You'd have theta on the right side and theta on the left side. So if you were to look at this particular triangle, one of these two triangles, you could say it's a right angle triangle in which you know that an angle is theta, and you also know that this side is R. Using this, you can now figure out, for instance, what this side is. You can figure out what SB is, and what you can also figure out is what the side OB is. Let's start with SB first of all, this side, SB. So if we use this triangle OSB, the shaded triangle, in this triangle, it's a right angle triangle, right? We can say SB is the opposite side, perpendicular. R is the adjacent side. What's the ratio between opposite and adjacent? It's tan. So we can say tan theta is equal to SB divided by SO, that's R. So we get SB over R equal to tan theta. And then what does that give us for SB? SB equals R tan theta. All right. Yes, that's good. Tan theta equals B over R. So Arham, that's also correct what you were saying there. If you use this triangle, you could say tan theta is equal to SA over R. That's also fine, right? That also works. So this is what we get. SB equals R tan theta. If SB equals R tan theta, what can we say about this complete length AB? AB would be 2 times R tan theta. We just multiply that by 2. So that complete length AB is now R into tan theta. Okay, AB equals R tan theta. So we have that complete side AB. Now let me just remove the shading now. We have that complete side AB. So now we have this side. And we have this perpendicular to that side, which is R. So we can just simply use half into base into height. Now we can consider AB as our base and OS as our height, and use half into base into height to calculate the area of the triangle. Let's do that now. Area of the triangle. Which triangle? The bigger triangle, which is OAB. That is equal to half into base. I'm sorry, I should have written 2R tan theta here. If SB is R tan theta, AB would be 2R tan theta, 2 times that, right? If half of this is R tan theta, the total length would be 2R tan theta. Okay. Now, half into base into height, base is 2R tan theta into height is R. That's the area of the triangle that we get. We can simplify this, 2 and 2 get cancelled, and we are left with R squared tan theta, right? This R into this R, that becomes R squared into tan theta. So what's the shaded area then? Shaded area would be area of triangle, which is R squared tan theta, minus the area of the sector, which is R squared theta. And that's your final result. Okay, you can take R squared common if you want, but it's not necessary. This is the simplified form. You can just leave it like this, and you can say that's the shaded area in terms of R and theta. Okay, that was the first part, where you had to find the shaded region. Now, what about the second part? The second part says, in the case where theta equals pi over 3 and R equals 6, find the total perimeter of the shaded regions, leaving your answer in terms of under root 3 and pi. Now, when it says leave your answer in terms of under root 3 and pi, that means you have to give an exact answer. Don't write values in decimals. Okay, don't use decimals, write exact answers. Okay, so there should be no decimals in your working. And you'll automatically get something in this form. Now we have to find the perimeter of the shaded regions. Perimeter is the length of the boundary of the shape, right? So what's the boundary of this shape now? The boundary is this complete length, AB, and then we have this length, AP. We have this arc length, PT, and we have this length, TB. We just have to add up all of these sides. That's all that we've got to do. And now we are given the values of R and theta. So we know that SB, for instance, is R tan theta. We can just input R and theta in this to find the length SB. We can just multiply that by 2 to find AB, right? We can also find this arc length PT using the formula S equals R theta. That we can also figure out. The only problem is, how do we figure out this length, AO or OA? We know what the radius is, and we can basically figure out this perpendicular, this side as well. Yeah, so we can figure out all of those sides. Let's do it step by step. So first of all, let's start with AB, for instance, the length AB. How do you figure that out? We have already calculated AB to be 2R tan theta in the first part. AB equals 2 times R into tan theta. All you have to do is put values of R and theta into this. What's the value of R? They have given that R should now be 6 and theta should be pi over 3. Let's just input those values. 2 into 6 into tan of pi over 3. Okay. Now calculate tan of pi over 3 on your calculator. Make sure that you show this working now. 2 into 6 is 12, but then what's tan of pi over 3 on your calculator? I think this is under root 3, right? Just confirm that. Make sure that your calculator is in radian mode, because the angle is in radians. So tan of pi divided by 3, that gives me under root 3. Okay, so AB equals under root 3. All right, now what else do we need? The arc length PT. What's the arc length formula? Arc PT. S equals R theta, right? R into theta. But now you have to be careful. The radius is R, yes. But the angle is not just theta. Angle in this case is 2 theta. So in place of theta, what you do is put 2 theta, right? The angle is 2 theta. So the angle that you use here should be 2 theta. So it becomes R into 2 theta. And now you just evaluate this. R is supposed to be 6. And then 2 into theta, which is pi over 3. Simplify this. This gives you 4 times pi. So you've got the arc length as well, the arc length PT. That's the second thing that we were looking for. So we have 2 of those sides now, arc PT and the length AB. What about AP and BT? We can just calculate one of them. Since they're supposed to be equal, we can just multiply that by 2. So let's find AP, for instance, the one on the left side. We know that OP is what? OP is R, right? OP is R. And we know the value of R now is, in the second part, the value of R is equal to 6. If we can find the total length OA, we can subtract from OA this radius, which is 6. Okay, let's check if you can still see my screen. Okay, Emma. Okay, my other device got disconnected, but I think it's back now. You can all hear me clearly, right?
Yes, sir.
Okay, good. Thank you. Okay, all right. So we know that OP equals 6. We can find the complete length OA somehow. How do you do that? Again, we can use this right angle triangle. We know that this length is R. We already know that this length now is R tan theta. We can either use Pythagoras in this, right? Or we can use trigonometry again because we know this angle is theta. So we can use trigonometry as well. So whatever you prefer, you can find OA using that. If you use Pythagoras, it's a right angle triangle, right? I'm talking about this triangle. OAS, you can use Pythagoras in this. How do you find OA? OA is the hypotenuse. So you can say OA squared, that is equal to R squared I'm sorry. R squared, why is it not writing? R squared plus R tan theta whole squared. And then OA would be square root of this. Now, since we know values of R and theta, let's put them here first. R is supposed to be 6, so that becomes 6 squared plus R, which is 6, into tan of theta, which means tan of pi over 3 whole squared. What do we get from this? 36 plus tan pi over 3 is under root 3, so it becomes 6 under root 3 whole squared. Now we get 36 plus 36, 6 squared is 36. Under root 3 squared is just 3. And that gives us 36 plus 36 times 3, which is going to be 144. So OA squared is 144. What's the length OA? That's just 12. Or you could just use trigonometry as well. I think that might have been quicker if you used, for example, sine here instead of using Pythagoras, since Pythagoras involved squaring lengths. That became a bit lengthy, but you could use trigonometry as well. Use sine or cos ratio with the angle pi over 3, and that will also work. You'll get the same result. OA turns out to be 12. Now, since OA is 12, anything about the length AP, we can say AP therefore is 12 minus the radius, which is 6, and that turns out to be 6. And now we can find that complete perimeter. We just add up all of these lengths. If AP is equal to 6, then this length BT is also going to be 6. All right, so we can say this is also the same as BT. So now what's the perimeter? Perimeter is just the sum of all of those sides now. So we have AB, that's 12 under root 3, plus 4 pi, the arc BT, plus 6 plus 6. And that gives us 12 under root 3 plus 4 pi plus 12. And you just leave it like this. You don't have to write it in decimals. You wanted an answer in terms of under root 3 and pi. You leave it as it is. That's your final answer. Okay, that's the perimeter of this shape. AB, arc BT, and the lengths AP and BT. Is that okay? Any problem with this?
No, sir.
No, sir.
No? Okay, let's move on then. So this was question number 17 from the worksheet. Okay, let's have a look at the next one. Okay, so there are a lot of questions that we have to do. It's okay. We will discuss all of them today. We might have to extend our class a bit, but I want to wrap this topic up today. So we will extend it if needed. Discuss all of those problems then, okay? All right, so we are done with question number 17. The next one is 16. Okay, let's have a look at this. Question number 16. Okay, this is a good question. I hope all of you had the chance to attempt this already, because then it would make a bit more sense. Okay, question number 16 from the worksheet. We have this diagram that shows a rhombus ABCD. Points P and Q lie on the diagonal AC such that BPD is an arc of a circle with center C. Okay, let me try to understand this first. P and Q lie on the diagonal AC. So we have these points P and Q such that BPD is an arc of a circle, BPD. So we're talking about this arc. This is the arc of a circle with center C. And BQD is another arc of a circle with center A. So we have two arcs like this. Okay. Each side of the rhombus is length 5 centimeters. So we know that these lengths are 5. All of these sides are 5. And the angle BAD, that means this angle, complete angle, is 1.2 radians. We need to find the area of the shaded region, BPQD. So that's the first problem, right? How do you find the area of the shaded region? Part 1. Any idea about this? How do you break this figure down to find the area of the shaded region? How would you describe the shaded region? Any idea?
Sector minus triangle.
Sector minus triangle. With sector minus which triangle? Draw a line from B to D.
Yes.
Okay, so that's the trick in this problem. Calculating this directly is going to be slightly difficult, but if you break it down like this, that you make a line from the point B to D, this line divides the shaded region into two parts. One part is below this line and the other part is above the line. So these are the two parts that you get from this. And these are two equal parts. And what you can do is you can find the area of one of these two parts, right? And then just multiply that area by 2, right? Yes, Aram, that's good. That's exactly what we should be doing here. Find the area of one of these two regions and then just multiply that by 2. Now, how would you find the area of one of these regions? It's a segment, right? This is a segment, the region that I have shaded here. You could consider this sector that I'm going to shade now. Find the area of this sector. Subtract from this the area of the triangle ABD. You'll get the area of that shaded region. Find the difference between the two areas. You'll get the area of the segment. Multiply that by 2. You'll get the complete shaded region. Okay, so let's do this quickly. So we need to find the area of the sector. What's the area of the sector? We're going to write it clearly. Sector ABD. That's the sector that we're talking about. Area of sector ABD. Half r squared theta. Radius is 5, right? If A is the center, the radius is going to be 5. Half into 5 squared into theta. Theta is 1.2. That gives us the area of the sector. Now, they have not asked us to give exact answers, so we can write values in decimals, and that's perfectly okay. So you just calculate this quickly. 25 over 2 into 1.2. That gives me 15. This is the area of the sector. What about the area of the triangle then? Area of triangle ABD. That turns out to be half into base into height. We can't use that. In fact, we can use half AB sine C. We have two sides. This is 5, this is 5. And we have the angle between them. So we can say it's half into 5 into 5 into sine of 1.2. Right? We use half AB sine C. And that should give us the area of the triangle. Making sure your calculator is in radian mode. So we have 25 divided by 2 into sine of 1.2. That gives me 11.65. Use at least 4 significant figures in your working, otherwise your answer is not going to be correct. Okay, not going to be accurate at least, and you will lose a mark for that. So minimum 4 significant figures in your working. So now what's the shaded area? In fact, first we find the area of the segment. Area of segment with segment BQD, that is equal to 15 minus 11.65. That gives us 3.35. And then we can say the shaded area is going to be 2 times this. That's 2 into 3.35, and that gives us 6.70. That's the area of the shaded region. Okay, because segment is half of the shaded region. We multiply that by 2 to find the total shaded region. Make sense? So this is something that you have to do a lot of times, that you have to draw a line like this in some diagrams to make your calculation relatively simpler. We did this in another example earlier as well. Question number 14 we did in our previous class. And that diagram, we drew a line like this, horizontal line, to help us with our calculation, right? So sometimes you have to do this. Drawing a line like this on a diagram makes things relatively easier to understand. Okay, so that's the first part, right? Not a lot of working for 4 marks, but you did need to think a bit about this, right? Okay, now what about back. What about the length of PQ? The length of PQ. How do you find this length PQ now? Let me just erase some of the stuff now. We know that these sides are 5. Why is this getting disconnected? Okay, so we know the area now, but now they're asking us for the length PQ. How can you find this length now? That's the question. Any idea about this? The length PQ. How do you find this length? Can you think of something?
So we say that PC equals to 5, and then because if we take the arc DCP, we could say that PC equals to 5, and then if we
Yeah.
have the line D to P, it shows that there's a triangle, a right angle triangle. We could find the height of the midpoint of DP to C, and then we subtract 5 from that, and then we multiply it by 2.
Okay, so that's good. So what we can do is we can draw that line here again. Calculating this length PQ directly is going to be slightly more complicated. So what we do is we again break this into two parts. Just like we broke the area into two parts, what we do here is we say, let's break PQ into two parts, such that we have a point in the middle here. Let's call this something. Let's call this point X, for instance. If we can find one of these two lengths, either PX or XQ, we can then just multiply that by 2 to find the total length, right? Now, how do you find PX or XQ here? That's the question. For that, we could use one of these sectors. For example, if we use this sector, just like before, we could use this sector and this triangle. If we call this point X, can we somehow find the length AX? We already know the length of AQ, remember? Because ABD is a sector. So AQ is also the radius of the sector, just like AB is the radius, AD is the radius, AQ is also the radius, right? AQ is also the radius. AQ is going to be equal to 5. That's something that we already know because that's the radius of the sector. AQ is the radius of the sector. If we can somehow find the length AX, that's this length from A to X, we can subtract that from 5 and that will leave us with the length XQ. So we can find this length XQ. And if we have that length XQ, we can just multiply that by 2 to get the total length PQ. All right. So now the problem is, how do you find the length AX? For that, we could think of this triangle. We could think of this triangle, ABD. This is an isosceles triangle, right? It's an isosceles triangle. If we draw a line from A point X, the angle that we get here is a 90 degrees. It's a property of rhombus as well. We will do this in coordinate geometry when we do that. In a rhombus, the diagonals are always perpendicular. Okay, in a rhombus, the diagonals of a rhombus are always perpendicular and they're also bisectors of each other. So we basically say the diagonals are perpendicular bisectors in a rhombus. So this point X is also the midpoint of the diagonals, and also the angle at the point X is going to be 90 degrees. So this angle is 90 degrees. What that means is, if this angle is 90, we could think of this triangle AXD, right? We could think of this triangle. It's a right angle triangle. If the total angle here was 1.2, what about this half angle on the left side? This angle would be 0.6. Now we have a right angle triangle in which we know one angle. We know the hypotenuse. We can find the length AX, right? AX is something that we can find now. Let's find that length AX. Let me make a right angle triangle here, just so you have it in front. The triangle that we're looking at is this one. So it looks something like this. In this triangle, we know that this is a right angle. This length is 5. And the sides are A, D, and X. This is A, this is D, and this is X. What we're looking for is the side AX. We know this angle is 0.6. How can you find AX? AX is adjacent to the angle. 5 is the hypotenuse. What's the ratio between adjacent and hypotenuse? It's cos. So we can say cos of 0.6, that equals AX over the hypotenuse, which is 5. So AX is equal to 5 cos of 0.6. And that should give you the length AX. Let me calculate that. 5 cos 0.6, that gives me 4 0.127. That's the length AX. Now, once we have the length AX, can we find XQ now? XQ is now going to be AQ, which was 5, minus AX. So it's AQ minus AX, that's 5 minus 4.127, and that gives you 0.873. Let's confirm that, 0.8733. That's what we get using our exact value from the calculator. So now that we have the length XQ, we can just multiply that by 2 to get the total length PQ. All right. And let's see what that gives us. PQ equals 2 into 0.8733. And that results in 1.7466. If we wanted to round this off, we could write it as 1.75 to 3 significant figures. And that's the length PQ that we were looking for. Make sense? Again, not a lot of working, but a lot of thinking, because we had to somehow figure out how to break this length down. We were looking for the length PQ. What we said was, we said, okay, let's break it down into 2 parts. Find half of it. How do you find half of it? You know the radius of the sector, that is 5. Subtract from that the length AX, that gives you 1/2 of this length. Then you just multiply that by 2 to get the total length. Is that okay?
Yes, sir.
Naima asked that question. Naima, is that okay to you?
Yes, sir.
Okay, now let's look at the next one. So Rajal has 1 question, then Aima has 3, 4 of them. So let's start with 1 question from Rajal, and then we'll discuss the ones that Aima sent. Then Rajal, do you have the paper number for this question? Yeah, it's written there. I'm sorry. You can just see what it is. It says Winter 9, paper 2, question 11. Okay. Winter 9, paper 2. What does that mean? Is it from AdMaths? Because that's not, we don't do paper 2 here. Rajal?
Sir, I found the question online. I'm not sure.
Okay, so it says paper 2 here. So paper 2 does not actually have circular measure. Okay, let me just find another way to copy this. Maybe I can do that here. I'm sorry, I'm just trying to figure out a way to send it to my iPad. Okay, I think maybe if you can try. Okay, I've got it down. Thank you. All right, let's try this now. Yeah, it's visible. In the diagram, ACB is an arc of a circle with center P. ACB is an arc of a circle with center P. So we have this arc, ACB. Center of this arc is P, and ADB is another arc of a circle. And the center for that is Q. Okay. Angle AQB is pi over 3. That's shown on the diagram. AQ and BQ are equal to 3 centimeters, and AP and BP are equal to under root 3 centimeters. All of that is given in the diagram. So are you talking about the last part in particular, Rajal?
Yes, sir.
Okay, all right. So first part, you have shown that the angle APB is 2 pi over 3. APB, this angle, is 2 pi over 3. So for that, you basically just subtract pi over 3 and this pi over 2, because it's a 90 degrees angle. It's a pi over 2 angle, right angle, because of the tangent meeting radius. And this is also right angle. So subtract from 2 pi the rest of the angles, you'll get this angle, which is 2 pi over 3. You've proved that in the first part. You found the perimeter of the shaded region as well. I'm just adding the two arc lengths. Now in the last part, it says find the area of the shaded region. Now for that, all you have to do is just divide this shaded region into two parts. Because it's not a standard shape, right? It's not something that you know the formula for directly. What you do is you break it down into two parts like this. Draw a vertical line from A to B. And now you have one segment on the right side. And you have another segment on the left side. You just find the areas of these two segments one by one, and then add them together. Okay. Let's start from the orange one, for instance. For that, you consider this whole sector. From that sector, subtract the area of the triangle. So from this sector, subtract this triangle. It's not showing for some reason. Yeah, subtract this triangle. Okay, so let me just do that here. Area of sector. Now, since there are multiple sectors here, you have to be very specific about what sector you're talking about. So area of which sector? The sector PAB. What is that going to be? Half r squared theta. Radius is under root 3. So half into under root 3 whole squared into theta. What's the angle? This angle, you have shown this in the first part. That's 2 pi over 3. That's 2 pi over 3. Area of the triangle PAB. What about that? That's half AB sine C. That's half into under root 3 into under root 3 into sine of 2 pi over 3. And you can see what that turns out to be. It's 3 over 2. Under root 3 into under root 3 is 3 divided by 2 into sine of 2 pi over 3. Just do that on your calculator and see what that gives you. Sine 2 pi divided by 3. That's giving me under root 3 over 2. All right. In fact, it doesn't ask you to find an exact area. So you can write this in decimals as well if you want. But this is giving me 3 under root 3 over 4. In decimals, that would be 1.299. All right. So that's the area of the triangle PAB. So what's the segment then? Area of segment the first segment that we have shaded here, ACB, that is going to be area of sector, which we did not calculate first. In fact, 3 divided by 2 into 2 pi divided by 3, that is just pi. Yeah. So this is going to be pi minus 1.299, which is 1.8426. That's the area of one of these segments, ACB, the one that I've shaded here. You can find the area of the other segment like this as well. So now you focus on this sector. Think of this sector now. Subtract from the area of the sector the area of this triangle, and that will give you the area of this segment. So do the same thing here, right? So find the area of sector. What's the sector? The sector is QAB. Half r squared theta, radius is 3 here. Half into 3 squared into theta, which is pi over 3. And that gives you 9 over 6 pi, which in decimals is 4.712. Okay, find the area of the triangle QAB. Like before, half into AB sine C. So the sides are 3 and 3, the angle is pi over 3. So half into 3 into sine of pi over 3. Let's see what that gives us. 9 divided by 6 into sine of pi divided by 3. And that's giving me okay, I'm just checking why does this turn out to be the same as before? Okay, I know. Into 2. 9 divided by 2 into sine of pi divided by 3. Okay, so this is 3.897. Okay, now what's the area of the segment? Area of segment, which segment? ADB. Area of segment ADB is 4.712 minus 3.897, and that gives you 0.8149. You've got the area of the two segments, the areas of the two segments. You just add them up, you get the total shaded area, right? So you have the area of this segment, you also have the area of the other segment that you calculated earlier. Now you just add them up, you get the total shaded area. What does that turn out to be? 1.8426 from here plus 0.8149. Let's see what that gives us. This turns out to be 2.657. We can say that's 2.66. That's the shaded area. Make sense?
Yes, sir. Thank
Right? Okay, so just calculate the area of the two segments separately and then just add them up together. Okay, now let's do a few more. So there are some questions that Ima posted on the other, on that WhatsApp group. In fact, Ima generally comes up with some very good questions from recent papers. Let's have a look at them as well. We're going to extend our class. So I hope you can stay back. If you have something very urgent, there's some emergency, then you can leave and watch the recording later. But I would really suggest that you stay back if there's nothing very important, because these seem to be some good questions that she has shared in the group. Okay, so we have October, November, Let me write that here. November 21, paper 1-1. Question number 6. Paper 1, circular measure, worksheet. Okay, no, not worksheet, I'm sorry. I have winter 21 here. Should be everything. Okay, let's look at this. The diagram shows a metal plate. The diagram shows a metal plate, ABC, in which the sides are the straight line, AB, and the arcs AC and BC. The line AB has length 6 centimeters. The arc AC is part of a circle with center B and radius 6 centimeters. And the arc BC is part of a circle with center A and radius 6 centimeters. Find the perimeter of the plate, giving an answer in terms of pi. So again, you have to leave your answer in terms of pi. You can't use decimals. Now, how do we think about this? Perimeter of this plate. Perimeter is the length of all sides, right? So one side is already given, that's AB. So all we're interested in is the length of AC and the length of AB. Now, what's AC? AC is part of a circle, it says, with center B. So B is the center of the circle, and you have an arc made like this. And the radius of this sector, of course, is 6 centimeters. That's the radius. So you could make a sector like this. Right, this is the sector that we're talking about. How do you find the arc length of this sector? You already have the radius. The only thing that you need to find is the angle. If you can find the angle somehow, this angle, you can figure out what the arc length is. Okay. I'm sorry. Now, how do you find that angle? We know that this side is 6. The radius of the sector is 6. If this is 6, if this side is 6, that means this side is also 6, right? Because that's the radius of the sector. They also tell us that the arc BC, part of a circle with center A and radius 6. So we also have another sector like this with center A, and BC is an arc of this circle that has center at A. This part also has radius 6. That means this is 6, and this length here is also 6. This is also 6. Does that make sense? So that basically gives us that the lengths of this triangle ABC are all 6. So it's an equilateral triangle. And if it's an equilateral triangle, all the angles are equal. The sum of all angles in a triangle is pi. So what's going to be each angle here? Pi over 3. 60 degrees is the angle that we have in an equilateral triangle. In radians, that will be pi over 3. So this angle is therefore pi over 3. And if that is pi over 3, this angle is also pi over 3, and the third angle is also pi over 3. So now we can find the arc length. We can find that the arc length AC is radius into the angle. What's the radius? Radius is 6. Angle is pi over 3. So that's 6 pi over 3. The arc AC turns out to be 2 pi. And if the arc AC is 2 pi, the other arc is the same. That's also the arc of the arc of a circle with radius 6 and angle here is also pi over 3. So the arc length there is also going to be the same. So this arc length is also for BC, right? 2 pi also is the length of the arc BC. And we also already know the other side, that's AB, that's 6. So what's the perimeter then? We just add all of those up. The perimeter is 6 plus 2 pi, that's the arc AC, plus 2 pi, that's the arc BC. The total turns out to be 6 plus 4 times pi. That's the perimeter of this plate. All right. Any problem with this? Is this all right?
No, sir.
So the lengths that we were looking for were these lengths, 6, and then this arc length and this arc length. So we know that those lengths are now 6, 2 pi, and 2 pi. That gives us the final result. That's the perimeter of this plate. Right? Perimeter is the length of the boundary. Then it says find the area of the plate. Now, once you've made this equilateral triangle like this, it's going to be pretty easy to figure out how to break this figure down now. So if you want to find the area of this figure, area of this whole figure, what you can do is you can find the area of the triangle and then find the area of one of these segments. The other is going to be the same. So you just multiply that by 2 and that will give you the total region. So how do you find the area of the triangle first of all? We could start from that, find the area of the triangle. It's an equilateral triangle. We know 2 sides. In fact, we know all sides. All sides are 6. The angles are pi over 3. We could use half AB sine C if we want. Let's find that area first. Area of triangle ABC. Half AB sine C. So we can say half into one side is 6. Another side is also 6. The angle between them is pi over 3. So that's sine of pi over 3. Let's see what this turns out to be. 6 into 6 over 2, that's 18. Sine pi over 3. Don't write down the final result directly. Please do write what the value of sine pi over 3 first of all turns out to be. So let me figure this out. Sine of pi divided by 3. And that gives me under root 3 over 2. So you first need to write this down. Under root 3 over 2, that's the value of sine pi over 3. This is important. And then you can say, okay, this turns out to be 9 under root 3. That's the area of the triangle ABC. Okay, because 18 and 2, they get cancelled. That gives you 9. So you have 9 under root 3. Writing down sine pi over 3 here is important. The value of sine pi over 3, that is important. Okay, so we have the area of the triangle. How do you find the area of one of these segments? You can find the area of the sector and subtract from that the area of the triangle, right? Find the area of any one of these sectors. So you can find the area, for example, this sector, ABC, right, this one. How do I mark that? Yeah. So this sector. Find the area of this sector, subtract from that the area of the triangle, you get that segment that we're looking for. Okay, let's try that. Area of one of those two segments, that's going to be area of the sector minus the area of the triangle. What's the area of the sector? Half r squared theta. What's the radius? Radius is 6. So half into 6 squared into theta, the angle is pi over 3. Subtract from that the area of the triangle. We've already calculated that here. You don't have to do that again. You just say that's 9 under root 3. What does that give you? 18 over 6, which is 3. That's 3 pi minus 9 under root 3. This is the area of one of those segments. Area of one segment. So now what's the total area? Total area is area of the triangle in the middle under root 3. So you have 9 under root 3 plus the area of the two segments. Area of one segment is 3 pi minus 9 under root 3. You add it one more time, or you can just multiply that by 2 if you want. However you want to do it. It should give you the same result. Now just add everything up. You get 9 under root 3 plus 3 pi minus 9 under root 3 plus 3 pi minus 9 under root 3. One of these 9 under 3's gets cancelled. 3 pi plus 3 pi is 6 pi. So you have 6 pi minus 9 under root 3. That's the total area of the plate. Okay, that's your answer in terms of pi and under root 3. Make sense? So you find the area of the triangle, add to that the areas of the two segments that you had there. Any problem with this?
No, sir.
No. Okay, let's look at the next one then. This is summer 21, paper 1-2, question number 1-2. Question 12. Okay, so this is the next one. Question number 12 from this paper. Okay, I'm at all parts of this.
Yes, sir.
Okay, let's start with this one. Part A and part 2. Okay, let's try this. We have this diagram that shows a cross section of 7 cylindrical pipes, each of radius 20 centimeters. They are held together by a thin rope which is wrapped tightly around the pipes. The centers of the 6 outer pipes are A, B, C, D, E, F. Points P and Q are situated where straight sections of the rope meet the pipe at center A. P and Q are where the straight sections of the rope meet the pipe at center A. Show that the angle PAQ is pi over 3 radians. Okay, part A. PAQ, what's that angle? PAQ is this angle. We need to show that this is pi over 3. All right, now how do we do the first part? So we have this circle and Q and P, you see points P and Q are situated, it says, where straight sections of the rope. So these are straight sections, the straight section, the straight section. they meet with the circle with center A. Yeah, so let's focus on this. In this circle, what we want to find is this angle. Now, since this line AP is radius to this tangent, we can say that we have a 90 degrees here, and in radians that will be pi over 2. We also have a 90 degrees here. If we extend lines from the center A to, for instance, this point here, we're going to have a 90 degrees here, and this angle here is also going to be 90 degrees or pi over 2. Then we are going to be left with this line here. We would have to find this angle somehow. To join these two vertices, that will give us a hexagon. That's a regular hexagon. Okay, so that's how. Sorry, yes.
Sir, why are you drawing these lines, red lines?
We are basically trying to figure out what this angle is. I'm just trying to think about this, how to find this angle, because we only know that these two sides are equal, right? Because they're both radii. And now we need to somehow find what this angle is in the middle. The radius is 20 centimeters, so we know that this length is 20, but that's not going to be of much help. And we know that this is this, and this could be figured out. It's going to be a regular hexagon. This is going to be an equilateral triangle. Okay, so one way to think about this could be, now it's a bit tricky. There could be other ways of thinking about this as well, but you see, all of these circles are equal. All of these circles have radii 20, right? Each of these circles has radius of 20. If we were to join A and B like this, and let's call the circle something. This is the other vertices are A, B, C, D, E, F. You can call this O, the circle in the middle. And if you make a triangle like this, what can we say about this triangle? About this triangle, we can say that this side is 20 and 20, this side is 20 and 20, and this side is 20 and 20, right? All sides are equal. Since all sides are equal, it's an equilateral triangle. If this is an equilateral triangle, what about this angle? This angle is supposed to be pi over 3, right? Now, if this angle is pi over 3, we could have a similar triangle here as well. This is also an equilateral triangle because, again, these sides are 20 and 20. This side is 20 and 20. This angle is also pi over 3. So this angle, I'm sorry, what happened there? This angle is also pi over 3. So in this circle, we know two angles now. This angle is pi over 3. This is pi over 3. This is pi over 2. This is also pi over 2. They're making 90 degrees, right? And we can find the remaining angle now. Now that's a slightly longer way of looking at this, but that's one way you could perhaps prove it. What's the angle in the whole circle? The angle of a circle is 2 pi, right? So you could say angle PAQ the one that you're looking for, this is the angle that you're looking for, right? This is equal to 2 pi minus the two right angles. One is pi over 2 here, another is pi over 2 here. Minus pi over 2, minus pi over 2. And given the fact that the other triangles are equilateral, we have these two pi over 3 angles. So that's minus pi over 3, minus pi over 3. That should give you what you want there. Let me just try. 2 minus 1 minus 1 minus 1 over 3 minus 1 over 3. And that results in pi over 3. And that's the angle that you were looking for. Does that logic make sense to everyone? Does that logic make sense?
Sir, can you please explain that again?
So basically what I did was, since we know that the radius of each circle is 20, the radius of each circle is 20. Let me just erase this again. Since we know the radius of each circle is 20, if we make lines like this, these are all equilateral triangles, right? You can make these triangles in the other circles as well, but we don't need them right now. All both of these triangles are equilateral. Why? Because the sides are equal, right? This is 40. This is 40, this is 40, this is 40, this is 40. All sides are equal. That gives us that the angles in these equilateral triangles are going to be pi over 3 each. This is pi over 3. This is pi over 3. These angles are both pi over 3, and if these angles are pi over 3, we know this is pi over 2, this is right angle. This is pi over 2. We just subtract from 2 pi all these 4 angles. So we subtract from 2 pi, pi over 2, pi over 2, pi over 3, and pi over 3, and that gives us this. That's one way of looking at this. Let me see if I can find another way of looking at this. Yeah, so this is one way you could prove it. Another way to think about this could be, but I think that's going to be more complicated. But another way could be that you say, remember a whole circle is 2 pi. Starting from P, what are the curved parts? These are the curved parts that you have. You have one curved part here, another curved part here, and another curved part here, another curved part here, then another here, and another here. And if you were to join these parts, that gives you a whole circle. Why? Because you're coming back to the same point again, right? So if you start from this direction, you're basically going like this, then this, 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 and then you come back to that same direction, right? So one other way to look at this could be, this figure is completing a full circle, the curved parts, right? How many such curved parts do you have in this figure? 1, 2, 3, 4, 5, 6. You've got 6 of these curved parts, right? So you have the same angle here, the same angle here, and then the same angle here, and the same angle here, and the same angle here. If you were to join these curved parts, of these diagrams, since it's completing one full circle, what's the angle that you have in a full circle? 2 pi. You have 6 such parts. You could say it's 2 pi over 6, and that gives you pi over 3. Does that make sense? That's another way of looking at it. If you look at these curved parts, they're going to complete one full circle, right? Because that this whole thing, the other parts are all straight. What's making it come back one full circle is this curved part. Are these curved parts? How many parts are these in total? There are 6 parts. In a full circle, we have 2 pi. Divide that by 6. Angle for each of these parts would be pi over 3. And that completes one full circle. So this could be the other logic. You divide 2 pi over 6. 2 pi by 6. It's a bit tricky, yes. Requires a lot of thinking. But let me know if these logics make sense.
Yes, sir.
Right? So you could use any of these. This could be another way to think about this. Okay, so now that we know what this angle is, the next part is find the length of the rope. Now, what's the rope? The rope is, the outer boundary. So this whole thing is the rope. We want to find the length of this rope. Okay, now how can we do this? So we already know we have some curved parts in this rope, the ones that I've shaded in yellow. And we know they complete one full circle. So for these curved parts, you could just use 2 pi r if you wanted, right? Because they complete one full circle. But if that makes it confusing for you, you can just find one of these arc lengths, PQ for instance, multiply that by 6, that will give you these curved. Okay, so find any one of these arc lengths, multiply that by 6. Okay, that's one part of the rope that you have outside the curved parts. Okay, let's do that first. Let's find the arc length of Q, for instance, arc PQ. That's going to be r into theta. Radius is 20, right? That's what it says. The radius is 20 into theta. Theta is pi over 3. That's the arc length PQ. Now, sum of all curved parts, that's going to be 20 pi over 3 multiplied by 6, and that gives you 40 pi. So that's all the curved parts of this figure. Okay. Then what about the straight parts? The parts that are left now. We have this part, this part, this. How many are these? 1, 2, 3, 4, 5, 6. So there's 6 of these parts now. How do you find the length of these parts? Let's think about this. The straight parts, for this, we could do something like this. We could say,
Sir, it's going to be 40.
yes. How do you figure that out?
Sir, as the radius is 20 and the parallel side will also be 20, so we will add it up and it will be 40.
Exactly. So if AB is 40, which we know is 40 because this radius is 20, this radius is also 20. That means Q to this point, let's call this something PQR maybe. This is R. QR is also 40. So one straight side, so all the straight sides have to be 40. We multiply 40 by 6. That gives us the length of all straight sides. So sum of all straight sides, that's going to be 40 times 6. That is 240. So the length of the rope that we were looking for, that's just the sum of these two. 40 pi plus 240, and that should give you the result. Okay, do they want an exact answer from you? They don't. So you can write in decimals if you want. It's 40 pi plus 240, and that gives us 365.67. Sorry, 66. If you want to round it off, you can round it off to 366, which is three significant figures. Okay, so that's the length of the rope. All right, let's look at the next one. Then it says find the area of the hexagon ABCDEF. All right, so now we're looking at this hexagon ABCDEF. We want the area of this hexagon. We know the sides of this hexagon now. All sides are 40, right? Now, what we can do is we can divide this figure into parts because we don't have a formula for area of a hexagon. So we can divide it into multiple parts. How do we divide this figure? We know the center of the circle in the middle is here. We could perhaps divide it into triangles like this, I think. Yeah, that should work. So one triangle here, another triangle here. The triangles that we made in the beginning, these are equilateral triangles. This triangle, we have this triangle, we have this triangle, we have this triangle, and also this triangle. How many triangles do you have in this hexagon? You have 6 equilateral triangles. You find the area of any one of these equilateral triangles, multiply that by 6, that will give you the area of the hexagon. Make sense? Now, these equilateral triangles have lengths 40, right? So just find the length, just find the area of one equilateral triangle. Let me draw that here. This is 40, this is 40, this is 40. We know the angle is pi over 3 because it's an equilateral triangle. All angles are equal. Area of one equilateral triangle. What's that? That's half into 40 into 40 into sine of pi over 3. Okay, let's calculate this. 40 into 40 divided by 2 into sine of pi divided by 3. What do we get? We get 692.8. 82. Then what's the area of the hexagon? Area of hexagon therefore is 6 multiplied by 692.82, and that should give us the result. Let's multiply by 6. That is 4156.9 units squared. Okay, if you want to round it off to 3 significant figures, you could write it as 4160 if you wanted, but that's not necessary. You can leave it like this as well, and that's perfectly okay. That's the area of the hexagon. Make sense? Any problem with this? Any questions? This was, I think the second and third parts were not that difficult. Once you have figured out the first part, that's why they are, they've basically given you the answer of the first part already. So in case you're not able to figure out the first part, you can still do the rest of the parts, right? Is part C clear? Any problem with this?
No, sir.
No,
No?
sir.
Okay, let's look at the last one now. It says find the area of the complete region enclosed by the rope. Okay, so now what we have done is we have found the area of the hexagon. What we want to do now is we want to find the area of the complete region. So what regions are we left with now? We have the hexagon already. The regions left are these rectangles. So we have one rectangle here. We have another rectangle here. We have another one here. So these are actually rectangles because the angles are 90 degrees, right? I've not drawn this very accurately, but these are supposed to be all 90 degrees angles like this. because it's radius and tangent. So the angle between them is 90 degrees. So we have these rectangles like this. How many rectangles do we have? We've got 6 rectangles, I suppose, just like before. So we have 6 rectangles, 1, 2, 3, 4, 5, 6. Find the area of one of these rectangles, multiply that by 6. And then we have 6 sectors. So we have this sector here, and we have this sector here, and we've got this sector here, and this sector here, this sector here, and this sector here. So find the area of one rectangle and one sector. Multiply that by 6 and add the area of the hexagon to that. Okay, let's do that. Part B. Area of one rectangle. Do we know the sides of the rectangle? One side is 40, right? This side is 40. The other side is 20, right? Because that's the radius. One side is radius. The other side is 2 times radius. That's 40 into 20. Area of one rectangle would be 40 multiplied by 20, which is 800. Okay, now what about the area of one small sector? Sector OPQ on the diagram, right? OPQ, let's focus on this. We know the radius is 20. We know the angle is pi over 3. Let's apply the area of the sector, which is half into 20 squared into pi over 3. What does that give us? That gives us 400 divided by 2 into pi over 3. And that's 200 pi over 3. And now we can find the total area. Total area is the area of the hexagon, 4160. 4156.9 plus 6 times the area of the rectangle plus 6 times the area of one sector, because there were 6 sectors as well. And that gives you the total area, which is going to be 10213.5. That's the total area of the shape. Make sense? Any questions on this?
No, sir.
No?
No, sir.
I'm sure by this time, some of you are regretting joining this class in the first place because it's been a bit long. Can we continue? We have 2 more questions. Is it okay if we continue for maybe 20, 25 more minutes? Do I take silence as a yes? Okay, let's actually continue that. Let's do 2 more questions, but for that we need to connect my iPad to charger as well. What I'll do is I'll show you this question so you can think about this, and then I'll connect my charger. June 2021, paper 1, question number 8. 2021, paper 1. Okay, this one. Question number 8 from this paper. Let's have a look at this quickly now. Okay, my iPad is just about to die. I'll just show this to you. Have a look at this, and I'll connect the charger quickly. Okay, I think it's working now. All right, let me just copy the rest of the question. So part A, part B is this. Is that perimeter? I think it would actually been quicker if I were to just copy it from the picture that you sent. We'll do that for the next question. All right, let's have a look at this now. We have this diagram. This diagram shows, let me just check if my mic is unmuted. Yeah. Okay, so the diagram shows a symmetrical metal plate. The plate is made by removing two identical pieces from a circular disc with center C. So we have a circular disc. So it was actually supposed to be a complete circle. This is what it was actually supposed to be. And it says the boundary of the plate consists of two arcs PS and QR. So you can see that here. One arc is here, the other arc is here. And two semicircles PQ and RS. So this is a semicircle, and this is also a semicircle. With PQ and RS as diameters. Okay, so PQ and RS, they're both diameters. Let me just represent that here. PQ, this straight line, is a diameter. RS, the straight line, is also a diameter. The radius of the circle with center C is 4 centimeters. So that means if we were to join these points, this is 4. And PQ and RS is 4 centimeters also, PQ and RS. Remember, they're not talking about arc PQ and arc RS, right? If they were talking about the arcs, they would tell you it's arc PQ and it's arc RS. If it just says PQ like this, that's the shortest distance between the points P and Q, and that's the straight line. So this straight line is 4 centimeters. Okay, and this straight line is also 4 centimeters. Which means these triangles that we have, these are equilateral triangles. What happened to my straight lines? Yeah. So these are equilateral triangles because the radius is 4 and RS and PQ, they're also 4. Now the first part is show that the angle PCS, which is this angle, if we were to join P and C like this as well, this angle you need to show is 2 pi over 3. All right, now how can we do that? Let's think about this. Angle PCS, we need to show that this is 2 pi over 3. This is not given, we have to show this. So what we can do is, the triangle is equilateral. If the triangle is equilateral, that means this angle here inside is going to be pi over 3. So we can say the angle RCS, first of all, RCS is equal to pi over 3. Why are we saying that? Because it's an equilateral triangle, right? RCS, this angle is pi over 3. And then what about the angle PCS? The angle PCS would just be pi, which is the angle in a straight line, minus pi over 3. So we just do that. We say angle PCS is going to be pi minus pi over 3. Angle on straight line is pi, so pi minus pi over 3. That gives us 2 pi over 3. And that's what we needed to show in the first part. Make sense? That's the first part. Any problem with this? Is that okay? The first part? Now, the second part says, find the exact perimeter of the plate. Now, what's the plate? Plate is this yellow part. The boundary of the plate is just the yellow part. So we have to find all of these lengths, just add them up. These are 4 sides, 4 arcs. Let's find the length of these arcs now. How can we do that? Let me just get rid of this. We could focus on this sector now. Yeah, we could focus on this sector. How do you find this arc length? You know the angle. This angle is 2 pi over 3. You know the radius. The radius is 4. How do you find the arc length PS? Let's find that. Arc PS. Arc PS is going to be R into theta. Radius is 4. And the angle is 2 pi over 3. That gives us 8 pi over 3. That's one arc PS. That's going to be the same as the arc QR. So we say this is also the arc QR. Then we find the other arc. Not the arc. This semicircular arc, in fact. How do you find this? For a semicircle, we can just use 2 pi r divided by 2, right? This is going to be the center of the semicircle. If this complete length is 4, we know that's 4. Then this is 2 and this is 2. So what's the radius of the semicircle? The radius of the semicircle is 2. So you can say the arc SR the arc SR, the semicircular arc, what's that? It's 2 pi r, the circumference, 2 pi into 2, divided by 2, because semicircular arc is equal to circumference divided by 2. Or if you wanted to use S equals R theta, you would say the radius is 2 and the angle is pi, right? Because angle is this is pi. So that's 2 pi. Using this as well, you get 2 pi. Okay. And then you find the complete perimeter. Because of this R, if the arc length RS is this, then the other arc PQ is also the same. So what's the perimeter then? The perimeter is 2 into 8 pi over 3 plus 2 into 2 pi. And that gives you 16 pi over 3 plus 4 pi, which is 28 pi over 3. That's the perimeter that you have in the first part. The second part, in fact. Make sense? Any problem with this? Are you guys still awake? Can I have raise of hands for everyone? Just to check. You guys are still up? Haven't slept already? Abdullah, Arham, Aisha, Hazem, are you still there?
Sir, I have problems with pressing the reaction button on my laptop. I'm here.
Yeah, it's okay, good. Thanks. Okay, all right, so good to see that you are all here still. And hopefully it's making sense to you. Let's look at the next part now, part C. Now it says, show that the area of the plate is this, 20 pi over 3 plus 800 under root 3. We need to find the area of the plate. Now, what does the plate look like? It's all of this region, this sector, and this part here. All of this is the plate. Now, there could be multiple ways of dividing this plate. One possibility could be that you say, let me just get rid of all of this now. So how do you, we need to find the area of this plate now, okay? So one way to divide this plate could be that we could say, let's find the area of this sector. Find the area of this sector. Find the area of this sector. Could that work? No, not these sectors. They're not going to work. Instead, we could say, yeah, that's one thing that we could do. We could say, let's find the area of the circle. Find the area of the complete circle. Find the area of the complete circle. Find the area of the complete circle. And then from that circle, subtract the area of the semicircle and the semicircle, and also this segment and this segment. That's one possibility, right? Find the area of the complete circle, subtract from that the area of the two semicircles, and also the areas of those two segments. Now, finding the area of the circle is straightforward. Finding the area of the semicircle is straightforward. The only problem is finding the area of this segment. How do you do that? For the area of the segment, you would just say, find the area of this sector, subtract from that the area of the triangle, and that will give the area of the segment, multiply that by 2, that will be the area of both those segments. That's one way to do it. As a sort of another way, which might be slightly quicker, I think. No, that's the same amount of effort. So another possibility could be that you divide this like this. Find the area of this segment. Find the area of this segment. And then what you do is you find the area of this rectangle in the middle. From that rectangle, subtract this semicircle and this semicircle. and that should give you the area. But that's almost the same amount of effort, so it's not any more efficient. So let's use the first one. I think that's more intuitive, perhaps, or maybe this one. That's your choice. You can use any of them. So this is what we started from, right? Let's do that. Find the area of the circle first. Let's start with that. Now, again, this is the kind of question that I was telling you about. It says, show this. You have the final answer already given. So you have to be very, very clear in your working. You have to show what you're calculating in each step so that the examiner knows that you're not just working backwards from your answer just to get to that somehow, but you're actually doing it in a logical way. So write everything down clearly. So first of all, what we're doing is we're finding the area of the circle. So write that down. Area of circle is pi r squared. So pi into r squared. What's the radius of the big circle? It's 4. The circle has radius 4. So you can say pi into 4 squared. The area of the circle is 16 pi. Now from the 16 pi, we need to subtract some areas. What do we need to subtract? We need to subtract the areas of the semicircles. Let's find the area of one semicircle. Remember the radius was 2 for the semicircle. So area of a semicircle, let's call that, in fact, there's only one semicircle. So as in one type of semicircle, so we don't necessarily need to name that. So it's going to be pi r squared divided by 2, pi into 2 squared divided by 2. What does that give us? That gives us 2 pi. Area of two semicircles is then just going to be 2 pi multiplied by 2. Okay, so that's done. What we're left with is the area of the segment. How do you find that? Area of segment PQ, for instance. Let's find this. Now, there are multiple segments possible here, right? So one is PQ, SR, they are the same, but you also have this segment possible, right? This is also a segment. So you have to name it properly. You're talking about the segment PQ, all right? So let's write that down. Area of segment PQ. How do you do that? You would find the area of the sector. Which sector are we talking about? We're talking about the sector for PQ. You would say, find the area of the sector CPQ. Sector CPQ minus the triangle CPQ. That will give you the area of the segment. What's the area of sector? Half into r squared, radius is 4, 4 squared into angle. Angle is pi over 3, this angle is pi over 3. So pi over 3, subtract from this the area of the triangle, that's half into 4 into 4 into sine of pi over 3. What do we get from this? 16 over 2 into 16 divided by 2 into pi divided by 3, that is 8 pi over 3. Subtract from this 16 over 2, that's 8. You have to write it down first. Sine pi over 3. You have to write down the value of this first. Let's see what this value is to. Sine pi over 3. That gives me under root 3 over 2. So we first write it down, under root 3 over 2. Then we can simplify this. This simplifies to 8 pi divided by 3 minus 4 under root 3. Yes, we can't simplify this any further. It's 8 pi over 3 minus 4 under root 3. This is area of one segment. Okay, all you have to do now is subtract from the area of the circle. Right? We had the area of one full circle. We start from that. We say area of plate is equal to the circle minus the two semicircles minus the two segments. Now this is for your notes, so you remember what we're doing here. You don't necessarily have to write it down, but you have 16 pi minus 2 into the area of the semicircle. The circle was 2 pi, so that's 2 into 2 pi minus 2 into area of segments, which was 8 pi over 3 minus 4 under root 3. Now you have to show your working still. Remember, we are showing a given answer. So the working is really important. So what do we get from this? We have 16 pi minus 4 pi minus 2 into 8 pi over 3, that's 16 pi over 3. 2 into 4 under 3, that's plus 8 under root 3, minus and minus, that becomes plus, so plus 8 under root 3. Now, what do we get from this? The pi term, 16 minus 4 minus 16 over 3. That's 20 over 3. So 20 pi over 3 plus 8 under root 3. That's the area of the plate. And that's exactly what we had to show here. 20 pi over 3 plus 8 under root 3. We get that area. Make sense? Any problem with this?
No, sir.
No? Okay, one last question. Hopefully that will be quicker. This is May 17, paper 1, variant 1. P1, circular measure, worksheet. Oh, why do I open this again and again? Here. Okay, let's try this. Question number 8 from this paper. Okay, let's try this now. The last question, and then we end. Tomorrow we start trigonometry, inshallah. In the diagram, OAXP is a sector of a circle with center O and radius 10. OAXP, that's a sector, OAXP. Radius is 10. Center is O. The length of the chord AB is 12. That's given in the diagram. The line OX passes through M, which is the midpoint of AB. We make it makes 90 degrees here. That property, remember, 90 degrees when a line coming from the center makes a 90 degrees with a chord. That chord is divided into 2 equal parts. So this side should be 6, and this should also be 6. Okay. The shaded region is bounded by the chord AB and by the arc and so on. We need to show that AXB is 2.498 radians, correct to 3 decimal places. First part. So what we need to find is the angle AXB. What's the angle AXB? AXB is this angle. So let's draw this line here. This is the angle that we're looking for. Okay. Now what we can do is we can find perhaps one part of this and then just multiply that by 2, right? Let's find this part. Let's call this theta. Let's see if we can figure this out somehow. We know that side is 12, this side is 6. We could find this angle. Is that a 90 degrees? It's not. This is 12. No, that complete side. This is 10, that's 10. And that's 1. Okay, I'm just thinking. I think it's been too long for me as well. I can't think anymore. Okay.
Sir, can we use
This angle,
trigonometric
we could find
ratios?
this. Yes. So we can actually find this angle somehow. Once we have this angle, we could just find this by subtracting, or we can find that as well. I'm not sure. This angle is not 90. If this was 90, that would make sense. But this angle, we can't say this is 90, can we? We can't. Yeah, so sorry, what were you saying?
Sir, I was saying that can we use trigonometric ratios?
Yeah, that's but on which triangle? That's what I'm thinking.
Like on XBO.
XBO, where's O? Yeah, XBO. That's not a right angle triangle? That's the problem. That's not a right angle triangle. So XBO is not a right angle triangle. This triangle, we can't say it's right angle.
Sir,
Yeah.
sir, can we use MBO to find the angle?
MBO, yeah, so we can use MBO to find this angle. I'm just thinking if that's going to be too long. So once you have this angle, you can find this length as well. And once you have this length, we know that the total is 10. We'll find this, that length, and that. Okay, so one possibility is that we find that length first. Okay, so I was just thinking of direct way, but I think this is probably the quickest that we can do. That we use this triangle. Use this triangle first. It's a right angle triangle, right? To find OM, first of all. Can we do that? We can find OM. We can say OM squared plus 6 squared, which is MB. That equals 10 squared. 10 is the hypotenuse, right? So we are using the triangle OMB. That's the triangle I'm using. It's a right angle triangle. We can find the length OM. Now, how does that help? OM squared equals 100 minus 36. That's 64. OM equals 8. So we know the length OM is 8. If OM is 8, we know that this complete length was 10 because that's the radius of the sector. Complete length is 10. So we can find XM. Right? So we can find XM from that. What's XM then? XM would be 10 minus 8, which is 2. Now, if this is 2, now we can say this length is 2, and now we can use this right angle triangle. Knowing that that length is 2, this length is 6,
Sir,
we can find the
length is
value.
12.
No, 12 is this length. 12 is AB. 12 is AB. OX is 10 because it's the radius of the sector now. It's 10 here. It's also 10 here. It's also 10 here. OX is supposed to be 10. Make sense?
Yes, sir.
I think my screen is not shared anymore. What happened to this? Okay, now it's there. All right, so XM is 10 minus 8, which is 2. So now we know XM is 2. So now we use that triangle. We use the triangle BMX. In that triangle, now we can use trigonometry with respect to this angle theta. we know that the opposite is 6, adjacent is 2. So we can use tan. We can say tan of theta is equal to 6/2. And that gives us tan theta equal to 3. And theta is equal to what? Tan inverse of 3. Let's do that. That gives me 1.249. We want more accuracy because the answer needs to be correct 3 decimal places. So 905. That's what I'm getting. So what's that angle that they were looking for? AXB. We just multiply this by 2. 2 into 1.24905. And that gives us 2.498. And that's what we had to prove. Angle AXB is 2.498. Now, I'm not sure if there was a quicker way of doing this because that's 3 marks and we're using 2 different triangles. That's fine, not too long. But is there a direct way of doing this? I'm not sure. So 6 on this length. And that angle. This is the center. Angle at center is oh. So there was another way of looking at it, although that's a bit more complicated. What you could do is you could say this angle. That's quicker, right? That's quick to find. Let's call this X, for instance. This angle would be this is X, this is 6, this is 10. We can find this angle quickly. We can say this angle is sine X equals 6/10, right? Opposite over hypotenuse. That will give us the value of X. And sine inverse is going to be 6/10. That's going to be 0.64350. If this is X, we can also find this, right? This is going to be 2 times this. The total angle turns out to be 1.28100. That's the total angle that we get. And then what we could say, find this angle. Now I'll tell you why. What's this angle? Let's figure this out first. 2 pi is the angle of the complete circle, right? 2 pi minus this, that gives me 4.9962. You get this angle. Now remember that property of circle. Angle at center is twice the angle at the circumference. So if you were to think of that complete circle, this is the angle at center. And this is the angle at the circumference. So that angle would be half of this. And you can just divide this by 2. And that gives you 2.498. Okay. That's another way of doing this. That's much quicker. But I think most people find using circular measure, the angle part of the circle using a bit complicated. So yeah, that basically does it in like 2-3 lines, not 2-3, 4-5 lines quicker than this. Does that make sense? What I just did here?
Yes, sir.
Yes, sir.
Right? That could be another idea as well. Okay, anyway, let's get back to that. So I'm not sure if this is possible to figure out very quickly. The other method is like relatively easier, although longer. But yeah, okay, anyway, let's move on to the next part. Okay, now it says find the perimeter of the shaded region. Perimeter of the shaded region. We know AB already, that's 12. All we need to do is find the arc length AB. How do you find the arc length AB? Remember, it's not a semicircle. Okay, don't assume this to be a semicircle and AB to be the diameter. Arc AB is with center X, right? They've given this here as well, I think, somewhere. Have they? AB.
Sir, can we use Pythagoras?
For what?
To find AX and then find the sector, like then find the arc length.
Yes, so you're telling about the radius, right? So you can find the radius using Pythagoras. Yes, you find the radius using Pythagoras. You already have the angle, then you use that to find arc length. Yes, that's exactly what we should be doing here. I'm just checking if it says anywhere that X is the center for that arc AB. Does it say anywhere in the question here? OXB is a sector with center O, so one is the sector, and the line OX passes through M. OX is perpendicular to AB, bounded by the chord AB. Yeah, so arc of a circle with center X and radius X. Yeah, so it says that. So X is the center of this arc, this other arc that we're considering. Now, let me just erase some of this that we drew here first. Okay, so now we're focusing on this part. We know this length is 2 now. This is 6. We can find the radius, AX, by using Pythagoras, right? So we can say AX squared equals 2 squared plus 6 squared. AX turns out to be under root of 40. And that's the radius of the sector XAB. That's the radius of this sector, right? Now, what's the arc length? Arc AB. We're talking about this arc, right? So what do we call this? You can say arc length AB with center X. So arc AB, where the center is X. How do you find that? Radius into theta. So that's under root 40 into theta. What's the angle theta? We found this before. This angle is 2.498. Let's use that into 2.498. That gives us the arc length AB. Under root 40 multiplied by 2.498. And that gives us 15.799. Okay, that's the arc length AB. And then we just add 12 to that. That will be the perimeter. So the perimeter was relatively straightforward. 12 plus 15.799, that gives us 27.799. We can say that's 27.8. That's the perimeter. Okay, that was part 2. Now, it's a common theme in many of these questions that when they ask you to show something in the first part, if that part is difficult, the other parts are often much easier. So what a lot of students do is they look at the first part, they try that, they're not able to figure that out, they just leave the whole question. Please don't do that. Even if you were not able to figure out the first part for some reason, that's understandable. A lot of students in this particular exam would not have figured out how to do the first part. That does not mean that you leave out the whole question, because the point of giving you this result part is that even if you're not able to do this, you can still do the rest of the parts using this answer. So you know this angle already. The second and third parts become pretty straightforward once you know that angle. So don't leave the whole question because you can't do the first part. You can still get these 6 marks pretty easily. Okay. Yes, you should not get stuck at a question during an exam, because that makes you lose time for potentially easier questions later on. but you should not be skipping whole questions. Skip a particular part if you can't figure that out in a few minutes, but don't leave the whole question. Still try the rest of the parts if that's possible. In this case, that's possible because you already have the answer from the first part given. So you can use that in the next parts if you have to. Okay, so find the area of the shaded region. How do you do that? It's a segment. So again, that's pretty straightforward. Find the area of the segment. That's area of sector minus triangle. Let's just do that quickly. Part 3. So area of the segment, the shaded area, that's area of sector. What sector are we talking about? XAB. Subtract from that the triangle XAB. Area of sector, that's half r squared theta. Radius was under root 40 squared into theta. Angle was 2.498. Subtract from that the area of the triangle, half into one side is square root of 40, the other side is square root of 40 into sine of 2.498. Now, in this case, they do not need an exact answer. You can just calculate this directly from your calculator. 2.498 minus sine of 2.498. That is giving me this. I multiply this by 40 divided by 2, and that gives me 37.96. That's what I'm getting from this. You can confirm this if that's correct. Is that okay? 37.96? 37.96? Is that all right? Can someone confirm this calculation?
Yes, sir.
Yes. Okay, good. So that was the last part here. And that's it. That completes our topic. And these were some very good questions. Thank you, Aima, for asking these questions. And also thank you to everyone else for staying back. It was a pleasant surprise that you can basically attend a 2-hour session like this. In fact, it's been more than 2 hours now, 2.5 hours almost. So make sure that you're spending more time on doing some more practice yourself as well. Some of these questions, as it often happens when somebody else is doing it and you're just looking at it, you think that these were not very difficult. Why did Aima find these questions difficult? Well, if you were to try them first yourself, you would figure out that they were pretty complicated. Okay, so you only get better at doing these questions better by practicing a lot of such questions. So make sure that you're doing that you're attempting these questions yourself. You should be attempting at least 20-30 questions from every question right now before you start your yearly practice later on. If you haven't done that practice, then I'm telling you, when you start your yearly papers later on, you will find that you have forgotten a lot of this stuff, and it'll be hard to make up for that lost time then. So do this effort right now. For every question for every topic that we're doing, you should be attempting at least 20-30 questions. That's the bare minimum. Okay, you should be doing more, as many as you can, but the bare minimum is like 20-30 for each of these topics. So make sure that you're doing that, and hopefully you will get better at figuring these complicated questions out as well. All right, that's it. I'll see you again tomorrow. Allah Hafiz.
Allah Hafiz, sir.
Allah Hafiz.